I trade to see if it's streaming. And I'm gonna continue to do the recursion study today. So I think either I spent some time looking at this yesterday, and I think either I did the algorithm thinking about it in the wrong way, or actually, let me think. Either I did this one in the wrong way because it's not similar to the other one, so it's not a good representation of the other one, or I thought about it in the wrong way. So I'm gonna investigate this now. And I also did a variation of this where, let me put the timer here for 1.5 hours, where I subtracted the value from here, because I thought about it, if I'm making this logic, which is just simulating the stack to create the graph, I can do the same logic here for resetting the values, where each time I get to the base case, I just pop out of the global list, or I subtract the value from the way that it was before. And that way, each time that it pops off and goes back to the other level, it's going to reset, and it's going to be the same. So I thought that would be the solution for figuring out the algorithm on the other one. But the problem is that it creates an infinite loop here on this one. But it might be just because of the way that I created this example here. And that's the thing that I'm not sure about it. So I have to investigate because it's very complicated. So I wonder if it's gonna be too small to do like this, so I can look at both at the same time. Maybe it would be good to put this stuff in the bottom here so I can just, for now, let me think. What I did before was just step through this. I also added these colors. I think I didn't add this yesterday. So I added 3 different colors every time that it pops, that there is a return statement, to know like the flow of the thing. So in the beginning, I think that it goes from the first call of the function, then it does the call 41, which is, I think, is this one, and is adding 200. I made 200. I think I'll make 300 again, so it's easier to see. I think I have to run this again. So now I have root 0, then increase by 300 line 41, which is the first recursive call. And it's gonna go back and forth between the recursive calls. So 41, but then the problem is when it pops. So this is 51. So it calls here, then goes here, because I'm switching the player each time. And 41, 51, and then here is where it gets interesting. As the last one is 41. Then what I think it happens is that it pops this and goes back here. And that's why it changes colors here. So it starts off as blue, so because it's blue, it becomes orange here. But the interesting thing is the line here. It's still line 41. So how is that possible? And I think the reason why this happens is because of the return statement, because at this point, the thing is already, like, once it hits the base case, because the pot is never changing, is always gonna be, like, it's gonna pop and then hit in the same line, I think, but I don't know for sure. I have to run like this again. Oh, I forgot to put the breaking point. So yeah, I think what is happening is that once it reaches this last base case, then it starts the other thing that I don't understand is that in some of the situations there is the line is not the line of the function, is the line of these return statements here. And I don't understand why only in some situations that this happens, and in the other ones, like this. The thing is that it might be a mistake in the way that I'm creating the visualization. Which might be a problem, but I think as far as I thought about this, it seems like I'm doing it in the correct way. Like it's a accurate representation. So for example, here code's line is 29, which would be this return statement here. So I don't understand why in this situation only shows this line. Because it seems like I'm popping obviously every time there is a return statement. So, but then for the other ones, you would have to be these lines as well, because that's when it goes back. So I don't understand why it's not the last line that was executed is not that one. But it might have to do because of the way that the events happen, because of the way that I'm getting the line there. That's the thing. I think that's more likely what's going on. So, like there is a specific situation where the different line is the last line before it makes the connection. The other thing that I have to think about is that the way that I'm creating the visualization is I'm popping when there is the return statement. And then I add the next node, which would be the connection. So I think that's the thing that is wrong here. Might be wrong. Because the next node of the connection should be still the parent node, I think. So it would be like saying that this 6 should be this 4. Because when it reaches here, it reaches the bottom. And then on the return statement, it should go back. And this is the part that I'm popping the node from. So I'm popping this 5, which was the last one, out of the thing. So it goes back to this one. And then on the next iteration, it creates this one. So maybe that's correct. I think that's correct actually, because, and the reason why it creates this is because it's popping each time because it hits the base case right after, because it goes from here. But this is the thing that is tricky, and that I think I thought about it in the wrong way. Because the way I was thinking about it is that after it pops, the thing from the stack is gonna pop like all the way from the place, but maybe it still works, the algorithm still works, like it pops and then it continues running from the last position of the function from that point until it reaches like it goes on a loop, I think, from that point, but maybe not. Yeah, maybe it's because of the way that I created this thing here. Because if the base case didn't hit right after it got to the last base case, then I think it would go back one, and then it would create like more levels of the tree. I think that's why this might not be a very good representation of the other one. Because in the other one, what would happen, but I think it would be very similar in a way. Because if you have a situation where it hits the base case when it comes to the fact of stack, then every time I pop that from the stack, from the return statement, I remove the values, like the last value, then I think it would continue the execution from that point, like it is doing here, I think. And then it would hit most likely would hit the base case again each time, because it's very close to the effective. But I think the difference would be that when it pops twice, because what it does here, as far as I understand now, Like when it reaches the base case, it pops and then it continues on the loop. Because it goes from the last time that the last recursive call was made, which was inside of one of these loops. And then it keeps going on the loop with a different action, and then it exhausts the actions from the loop by going the recursion, because each one of them hits the final base case, which is the effective stack, which is this condition here. And then once it exhausts everything, then it goes back 2 levels, because then it goes to the parent recursive call that wasn't finished, because they're all nested in each other. So you would go directly from the last one here. And this is the reason why I put 3 different colors, is because I wanted to see if that's what's going on. So here the 9 is the last one, and it goes, so it's gonna pop the 9 and then pop the 4, so it pops twice, and then it goes directly from here and starts here again from the 10. So it goes from here to here, and the only way is to have 3 different colors to differentiate. So, and this is the way that I think it works. So once it goes from here to here, then the same thing happens again, where it starts the loop again from this point, but then every node reaches the base case. But it feels like it's wrong, but the thing is, I think it is wrong because of the way that the function works now, because I need to reset like the value somehow on this point, because the way that I think that it should work, the structure should work on the other algorithm, would be that each one of these nodes creates more levels here. That's what I think it should happen, because, but then again, I don't know if I made a mistake when creating the visualization here, or if this function that I created is not a very good representation as well of what's actually gonna happen in the line. This is the part that I'm thinking about now. Because if the only way that I'm updating the values is by every time there is a return, because I think that is different when there's a return and when it pops off the stack. That's the problem. But it should be the same. That's the thing. Because it should only pop the stack, the function calls out of the stack once it reaches the return statement. And then it should pop and then go for the last level that it didn't finish the execution, and continue from there, I think. That's what it does. So it goes to the last level, which is 5, then it pops. Then it continues the execution from the last place that it was, which is the last recursive call, which is inside of the loop. And then it exhausts this, and once it exhausts this, then it goes back again, and then it continues the thing from that one. But this is the thing, is because when it continues from the last loop, it should create more recursive calls. That's the problem. I think, and the issue is probably because of the pots, but I'm not 100% sure. Because when it reaches the last loop, then instead of hitting the base case each time on one of these parser, you should go into the other player's actions again. But I think the reason why this is not happening is because of the way that I created this function, which is not the same way. Because if I have a situation where in the actual poker game where I'm analyzing the line, then I think that if they get to the part where the bet reaches the effective stack, then you should create something like this, I think. But it's hard to think about. Yeah, because at each point of that point in the decision tree, there's going to be multiple different options for them to hit the effective stack. And the options are going to be all the possible bets and raises that both players can do from that point. So I think this is a good representation of the way of what is happening on the situation where they get to the effective stack. But then obviously here I can't analyze unless I make this more difficult, more complex, where I think about how to structure the lines in such a way that I'm gonna get to the end of the line. even if they don't hit the effective stack. That's the thing, but I'm thinking about like, whether or not this is worth it to do. Because I think I think that I don't need necessarily to have those cases to figure it out. But maybe I do. Because the thing is, yeah, I think that what I need to do is try to figure out the values of the pots. Like how to make it so that these values are the same. Like they are always going from 220 here. Because here, that's the obvious problem where... And I think as long as I figure that out, then I can extrapolate the logic to the other one without having to make this one very complex. Because the issue with making this one very complex is then I'm gonna like waste a lot of time thinking about all the possible lines and all the stuff like that. And then I'm gonna have to pass all do the calculations and the amounts and everything. But I might end up having to do that if I can't figure out. Because the two other situations would be either the player folded, which here is weird that is not, but it's not getting to this point because of the way that I structured the bets. That's the thing, because it always hits the base case there. But maybe it should get to this point, now that I think about it. Let's see, bats, euro, flop. So I'm using this one. So it should get to this condition at some point. But maybe it does, but it doesn't show on, let's see, 27. Let's see if there's any. I think I've seen one that is 27. Maybe not on this format, but on other visualizations that I did that are variations of this. Only 29. 27 here. So there's only one 27. Yeah, but this shows that it hits this point. But it should have two 27s here, I think. Because there's two here. There's only 24 as well. 24. Yeah, this is weird. Oh no, this is it's 41, not 24. Yeah. I'm tripping. But I don't understand why it shows 29 on these ones. I think it's because it's the last. It might be because it's the last recursive call that was made. So it's the last return statement. So because it is not executing any other line after, it doesn't show. At 36. This is also weird because it's just the line of the loop. So how is this possible? And the thing is, I don't understand really well. Like, I don't know if this is because of the event here. Because I'm capturing the line whenever there is the line event. The last time that there was a line event. So like, it's like there is a one delay. Because the graph is created based on the calls, which are always the main function. So I assume I'm getting the line one line after it executed the last line after it executed the function. Let me see here. I think it has to do with that, because all of these are... Let's see if there's any other lines other than 41 and 51 on these ones. It looks like it doesn't. So I think that the only situation where I have different lines is when it's the end of the function and there's no more recursive calls. Because in that situation, it hits the bottom, let's say. But it's still hard to think about. 25, 26. Yeah, 26 is the first one that has this line. And 27 goes to the 29. I guess this happens when... Yeah, but... I think... Like, why would this be the last line that it was called instead of all these other ones? I guess it's when it hits the end of the loop. And then 27 is 29. 28 is 29. 30 is 27. 31 is 29. And the also strange thing, you should have two 27s, I think. So let me run the debug here and see if I can. What I did before was follow this with the thing there. Yeah, so this hits this point. And this point. And this. This is why it's so confusing, is because for each iteration of the loop is doing a recursive call, which is changing the player. So it's like there's multiple calls that are all inside of the loop. And I think this is why it creates this structure here, because each time that it pops, the level, it completes the loop. But I think the way that I was thinking about it is not this way, I think. The way that I was visualizing in my mind in the beginning. The way that I was visualizing is more that it would return all the recursive calls from that point and then continue the loop again. Like, continue the loop from the base level, let's say. But actually that doesn't make sense now that I think about it, because it has to have this dynamic of going back and forth. But I think at the end of the day, it does get all the paths if I'm able to structure the thing correctly in such a way that it starts again from that point, the hand. The parameters of the hand are reinitialized up to the point that it traces back one time. Because then I think it makes more sense. I think I stopped on the 41. And 51 would be this one. I'm curious to see, I'm gonna try to follow up until the the point that it goes back to the last level. Just see here what's happening. And the thing that annoys me about this is that I can't go back, so like only if I go everything, I think. I can't go back one level. So this is 51. Then 41, just here. And now I think is the point where it goes back the first time. So it reached the bottom from the first, and now there's a bunch of nested nested recursive calls inside of the loops. So now curious to see. So I'm on the 5 here, which would be, and it goes back to the 36 right away, and then it continues on the loop. Then it's gonna call again, I think. Yeah, calls again. So this is this point, I think. And then reaches the base case, goes back to the 41. I think this might be the reason why it shows this line, because when it reaches the base case, it goes back to this line. Yeah, like every time that there is a recursive call, and there's still other recursive calls in the stack, is just the last line that is going to be executed is the one that made the last recursive call. So this would be the first return statement, because that's the last stack frame that was executing. That's the reason why I have these lines here. So on the parent one, what's happening is that it reaches like all of the previous frames, all the previous recursive calls were solved because all the return statements were exhausted through the loops, and then because there is no more recursive calls on the stack, like once it makes the return statement and pops that off the stack, the last line that would be executed is just the line that happened before instead of the recursive. I think that's what's going on. And then now it's gonna call again, which is gonna be the 8, and it's gonna reach the base case again. So these nodes, and goes back. Now it's the 9. It's this one. Yeah, now it should be interesting as well, because it's gonna go twice. So here you would have to go to the 10, which is line 51. Let's see. It goes back here. Oh, interesting. Maybe I missed the count, or something else is happening. And still, yeah, now we go back. Maybe I missed by one the counts. Now it goes back here. Or maybe there's something wrong. The main concern that I have is that if I did the visualization in the wrong way, because of the way that I'm connecting the nodes there and creating the edges, it might be possible. The thing is, I didn't want to create the edge when on the return statement, because then it's gonna just create the cycles. But maybe what I should do is just create an edge with a different color once that happens between. Yeah, but then how would I do that? Maybe I can use the global variable, which would be the color, and then I put, because I would have to connect the last node before I pop the node with the last node with the next node. So maybe, yeah, but I could just not pop and just stop the return statement and then create a different, but then how? I think to create a different color, I would have to create 2 different global variables for the color and then make an if-else statement to determine which one would be by creating a flag variable. think that that would be the way. But then the issue is that the graph becomes more confusing, I think. Because you would have just the loops here that would show this path, like the last node going back to this one, and all of these ones like going on a cycle to this one, and then this one going to this one. Or what you would do is just override this edge here to go on the other way. But I think you would create a new one. But I think I can try that. Yeah, I'm thinking how I would do it. So the best way to do it so that I have the edges that show the path backwards. And I don't know which one would be better to visualize. And let me continue the execution here, then I'll think about this later. So now I imagine it would be at this point, 11. 12. 13. It's interesting that I think it's missing a node here. And it might be because of the way that I created the connection. And this is the reason why there is only 127. Because it might be the case that instead of popping, I need to add another node when it returns. But then the issue is that if I do it like that, it creates the cycles there. And now it goes back to here. Party 1. I'm gonna go faster because I think it's gonna do the same thing until I go back to the 51. So here it hits this case here. Because it's hitting this every time for each recursive call. So the last one is always going to be a fold. So there should be, but maybe it's because of the stuff that I talked about, the recursive calls, that it doesn't have the other one, like the line for the fold at each step of this cycle. And now I think it's here again. And now, see, it starts with this one. It pops this. So I think I understand now, because in the last the last action of this thing, it goes back to this line. That's what's happening. So it is correct here, the number of nodes, I think. But in the last one, it goes back to this one and then goes back to here. And then from here, it goes back to here. Should be here. So 21, 22. And then it's gonna exhaust, I think, the actions for this time. At 22, 23. Here. Now it's 24. $25. And now this is the last action. And this is why it shows 26 here. Shows 36 the line. Because from here it goes back. And I forgot about this one. Because this one is the main one. So that's the reason why it has the other like this. Because each one of these would be a different tree, I think. Not each one of these. Like one of these would be the parents of each one of some of these. If the pot wasn't already at the limit. And now it just calls recursively there. Like it just fits the base case for the other ones. 27. And this is why it shows the line here instead of showing the recursive. Now it makes a lot of sense. Yeah, so the question is, how do I think the first thing I have to do is think about a way to remove some value out of the pot so that it's like it is resetting the hand from the point. But then the problem is that it's gonna create an infinite loop if I do that. So I think I thought about it in a slightly wrong way. About the way that you create this. But it's hard to think about another way. Yeah, let me ask, like, what would happen if when it reaches the base case, which is like the last node out of this thing? What will happen if I decrease the value for this? Yeah, the problem is that it creates an infinite loop. That's the thing. No, but it should reach the last value here. So, I don't know, it should work in my mind. Like, if each time I have the return statement here, I subtracted from the pots the amount that I added. Like, but it says that I reached maximum recursion, so I think obviously it should be wrong, but I don't understand why it's wrong. Because here, in the first iteration, I'm obviously gonna be adding a lot more. But the issue is, I think that it never stops the recursions, because then like it's gonna go back again forever, maybe. Because there's no way to remove all of the calls. Maybe that's the reason why. Yeah, but the thing is that at that point, So what I'm thinking about is I'm gonna get reach here and then I subtract and then it goes back here. So and this iteration is gonna exhaust everything and it's gonna be everything's gonna be the maximum. So it would be instead of here having 2800, we would have 2500 on all of them. And it's weird that here and this shoe is also not adding the thing. But I guess it's because, well, actually, I don't know. Oh, it's because of the type of action, probably. Yeah, so I think the ones that don't add is because of the type of the action. So it adds here, here, and here. And then on these ones it's call and fold. That's why. But, okay, so let's say every one of them is 2500. Then when it pops twice, it's gonna decrease by twice, and you would have this value here from this one, which would be 2500 minus 600. And then from this point, it would execute. But then the thing is, like, I don't think you would create an infinite loop if that was the case, because this option was already exhausted, I think. Like, it already visited this path. So this might be the place that I get it wrong, because it is reaching maximum recursion depth. So if I subtract, so it might be the case that it just goes through this path again, but that wouldn't make sense to me, because it's like this path is part of the loop here. That's the thing. But this might be the thing that I'm getting wrong. Because I was also thinking about it in my head, I think, where it's gonna pop like twice and it's gonna continue looping. But the way that it works is just goes to the bottom, and then the first time that it pops, it loops, it goes through the whole loop. And then when it pops twice, it just goes through the whole loop again from that point. But the thing is, if I'm changing the pots, then it would increase because it would recurse again. That's the thing. If I remove the pots, instead of doing like this, where it just stops here, it would go back, like it would create other trees here. But it shouldn't create an infinite loop, I think, in my mind. Because it's still going through it's still exhausting the loops from that point. Oh, but it might be the case that it just creates forever the same thing. Like the same thing that happens on the last level here. But then that doesn't make sense anyway. Maybe it does, because like it's doing other recursive calls. So it pops off, and then because the pot is not lower, because the pot is lower, then it's gonna call recursively as well. Again, instead of doing limiting here, it's gonna call recursively. But it's still hard for me to think. I don't know. So how do I figure out what is wrong here if I do it like this? And so here I'm subtracting the same value that I'm adding here, here and here. So if I add the same amount that I remove, then it creates an infinite loop. So that should be the only explanation. But if I'm adding more, then, because in the first path, it's gonna add a lot more. And then it's only gonna remove when it's backtracking to the other nodes. So it continues the iterations from that point. The problem is that the iterations involve recursion. That's the issue. So it might go back and forth forever. And that wouldn't make sense. Yeah, maximum recursion depth exceeded. Maybe what I need is a like more simple example so I can see what's going on. Instead of having two recursives, I do just one in a loop. The intuitive problem, I think, the way that I think about the problem intuitively is that it's the same levels, like I'm adding and subtracting the same levels. So the amount that I add here to the pots is the same that I'm subtracting, and that makes it so that it never stops running because they're equal, so it creates a cycle. But I don't understand, like, don't know how in the execution of the thing. Maybe I should try to go with the debug here. I think the other thing that I can try is to do another simple, like a function that is more simple. Hmm. Oh, that's why. Because they're gonna go there forever, I think. So I think, oh, but it should pop twice. That's the thing. Because it should have this behavior on the last one, I think, of adding and subtracting the same amount because you reached the base case. So it should go from the last points and then keep all of the stuff the same and exhaust the loop from the last point and then go back twice and keep going. Oh, maybe that's why. Hmm. Maybe this is the thing that is fucking it up. I think what I can do is just remove these actions from the thing and just make it with the pot first, so it's easier to think about it. Because here is gonna be a different situation. Like it's a different base case. There's the C here, I think. I'm also passing the action for the villain when in reality is the hero action because it's the one that I called recursively. So this is the C action from the hero, so he hits this base case here. Maybe let me see the global variables. The pots. Maybe we should look up an algorithm should find a cycle in our recursion and then implement that here. And the question is, how would I implement? Seems like a very hard thing to think about. Maybe this is correct, but it just hits the limit because the tree is too big, but I think it's more likely there is a cycle somewhere. And just with the debugging tool is not gonna be enough. Because I can't keep track of what happens with all the calls. I just see it's gonna take a long time to get to the place where he fucks up. I think I'm gonna remove this thing here. Maybe what I can also do is just return there instead of doing that. Instead of decreasing the pots. But I also think that this one is not gonna work. But I just wanna see. Also, it does work now. Interesting. So that's great because then I can visualize what's going on. It's a lot bigger than the other one. Might be the case that it's just too big. But that doesn't make sense to me, because how would it be possible to create the algorithm? Like, if that was the case. You got all the poker lines. Fuck. That's taking a long time. Now, what is difficult is that I have to think about this as well on the other one. Like, if it works, then it's still a problem, because the actual case is going to be a lot more complex. Because I have to subtract a lot more things, change a lot more things. So I need to figure out the fundamental thing here. The fundamental logic of what needs to happen when it's backtracking to update the values in the way that is going to allow me to have all the lines, but without getting into an infinite loop, or getting the maximum recursion depth exceeded. I think I'm gonna stop this, and I'm gonna check to see if I weighted correctly for this one. Yeah, so it looks like it's really fast here. So it is running normally. So this one just takes a lot more time because I'm doing all of this stuff. And the graph is probably gonna be massive. Because now what is happening is that, as far as I can think, is every time there is after the final cycle there, it's gonna finish that one, but then from each point of the other cycles is gonna go and create a whole other tree that is pretty much the exact same shape as the main one that I had there in the beginning. But it's gonna be, and then it's gonna do that until it reaches the final case on that one, and then goes through the loop, and then it's gonna go from that point again, and then go into the another direction, and it's gonna create all of these different trees from that one. So it's gonna be a massive tree, I think. And I have to think about it. It makes sense the way that it is there, or the logic to update, and why if I put the other logic there to subtract when there's the bats, it doesn't work. But I think I understand why. Is because I'm not adding the pot for that action. So, and this is the issue, is because the way that, but I think that I get it now, is because I'm creating an asymmetry there. That's the problem. Is whenever there is an action, I have to subtract only the action when there's a return statement. So for example, in the call, I'm subtracting the that amount from the pot, but the action itself is not increasing the size of the pot. So the correct way to do that there would be just to return when there's a call instead of subtracting. because the type of action has to be directly symmetrical with the way that it changes the hand. So I think that that's the main logic there. And if I do like that, then I think it's going to work, but it's just going to be like a very massive tree, I think. It's just going to make it... Maybe what I can try to do as well is try to move this stuff. No, yeah, I have to think about this as well. Because if I'm going to do the visualizations thing, it would be good if I could somehow like allow, like upload the software and then do the visualization based on the software. So obviously the simplest thing you can do is just create a main file where you have all the executions you want to have for the whole software, the connections you want to understand, and then you put that inside of the stat trace. And then because those files are going to use other files through the imports, the stack trace is going to show everything that is executed, obviously. So you actually don't need to put a lot of code inside of here. You just put the file that activates the code. But then the issue is that you need to have all the files in the software inside of here. So maybe there's another way to do it. Because what it would be, I think the graph would be too complicated, but I think it would be at least interesting to try to put the other function here, like this project, this file, the execution of these functions inside of this other one, the stat trace here. But then, like, the only way to do that is if I put the project, I think. If I copy the entire project that I have here, which I think I might do actually, because it's not just like it's not a lot of files, and I can just create another folder there, and then I create another file here that has all the functions of this file that I want to analyze. But I'm thinking about it also, how would I do it to put on the website. The way that I think about the website more now is just to do something like Python Tutor does, where they have some space. But I would, like, it would be good to create something that allows people to visualize. I want to create something that allows people to study software design based on what actually happens in the libraries. So associate the concepts with what happens in the library based on the connections of the files. Because that way it would allow you to create something that maps the data structures, how the data structures solve the problems. Because that's obviously the connection that is going on the lower level. Is that the computer doesn't understand software design, it just understands the... So there's this massive complexity of data structures that when they are structured in a certain way, they solve a problem. Because it creates an informational field that solves the problem. So if you can create something that makes a connection between the two, like what is the problem on the concept level and what is the geometrical structure that is used to solve the problem, that creates this computation, because that's all the computers are. The hardware is extremely complex geometrical thing that creates the field, that creates the information. So it's just the manipulation of voltage that creates the electromagnetic impulses through a geometry, creates the field of information. And then based on that, you can change the field by inputs on the mouse and the keyboard. And those inputs change the informational field in such a way that you have all this logic in the file that programmatically changes or does whatever you want it to do. So there's always the connection between, and yeah, because then the IDE communicates with the code for the file, which communicates with the operational system, which uses the memory in the actual data structure, in the actual hardware, to create the data structures. And then that manipulation of the data structures is solving a problem. which is an informational thing. Because every problem in software is the creation of a informational system that allows for some type of outcome, which is usually coordination, I think, because that's what websites are, and connection. So if you have the connection between that, like if you can create some structure that analyzes, like the graph thing that I'm doing here, that you create the connections of a complex problem and what is the geometrical patterns that are used to solve the complex problem. And then I think you can go as like lower or high as you can, because obviously it would be a lot more difficult to, well, there's both the way that you capture, which is the inside of the function, what do you decide to, how should decide to make connections. That itself is a data structure that's going to create the visualization. And then there's the actual data structure is being used to solve the problem. But maybe, yeah, from that point, you also don't need the visualization. It would be just creating something that captures the connections between data structures in a software and associating that with concepts, I think. So, because it would be much better to, instead of thinking about it, like instead of thinking about model view controller or some other type of system, you were able to see like all of the problems that exist and what is the pattern that is used to solve them in a geometrical standpoint, like how the functions connect to each other and how the control flow connects with everything else, and how like this structure of the electromagnetic field is creating an informational system that creates this thing that we call like a product that solves a problem, which is by itself the consequence of the computation of the market economy. So if you could create the link between the two with a machine learning system, I think that instead of having to study the software design, you would be able to get to automate from like a database or something how to solve problems that are similar, because you would be at the bottom multifractal pattern. So yeah, but then it gets really complicated, I think, because that, and this is the thing that's, I don't know, because it might be impossible to do that, because it's going to be multifractal, but it's going to have infinite complexity. But I think you can create something that compresses the geometry to solve the problems, but that would be like something, trying to create something like in AGI, I think, because that's probably what AGI would do, I think. Just create this cycle where it studies itself. Maybe that's the path, but probably I'm missing a lot of things that I don't know. Yeah, but for a simple website, I think that's what I can do is something similar to this, but then instead of having this, I would have the graph visualization that I have there, and then allow people to put multiple different options for both the way that they want to visualize, and this is the hard part, because then you have to generalize. So for here, for example, I'm using this structure based on the events, and then I simulate what it would be the flow of the stack frame to create the graph. So the question would be how to generalize this structure here so that I can allow people to choose different things without having to think about this, to structure the graph in a certain way, to capture like both the software design of an application. So for example, like Django, like how do you create the connections that show the representation of the software design of a Django application, and then how do you show the variations of that? Yeah. Yeah, so for here, for example, that's what they do. Right, they're showing this stuff, but instead of having this, I would have the graph, the network acts, where people can, and then each node can have, like you can navigate with the keyboard, and then each node would have some functionality as well. And then you would be able to debug with people as well, like on a thing, through a WebSocket. It looks like this is gonna take a long time. So I think I might stop here. Maybe I'll come back today, but probably not. I always say that I'm gonna come back, but I don't. And I think I'm just gonna wait for this to finish. Yeah, I have to wait because I need. I don't need, but I want to see the graph. I want to see, like, to reason about this, if I'm thinking about it the correct way. Because if this works, then I think I know how to create the other algorithm. Then it's going to be a question of whether or not, because this is already taking a long time and it's very simple. And the other one is going to be extremely, like, it's going to be way more complex because I have to add the nodes and I have to do all the other calculations. So that's a challenge as well, because even though it might work from the concept level, the logic that I'm going to implement, it might not work because I don't have the resources. And because it is in Python, so it's already using more memory, I think, and is lower. So it might not be possible from that standpoint, even if it works, to create the whole tree like the way that I'm creating there. But I think that what makes sense to me now is that the way you should do it is to make this, like, make it symmetrical. The stuff that you're gonna remove, if you wanna keep the information from the points after the recursive calls, you make it symmetrical. You pop everything that you wanna pop from lists that are in global variable. You remove the last element that it was added for a dictionary, for example, and you subtract any values that you added. And then when you do that, every time that it pops the thing from the stack because it reached the base case, it's gonna keep the information from the last point that it had the bifurcation. And then from that point, it's gonna create the other branches of the tree based on the loops. So I think that logic makes sense to me, and I think it is correct. So I think that from this theoretical standpoint, it should work, but then in practice, it might not work because of the memory or... And the thing here is that I want to see the graph and think more about this because I want to make sure that this logic is correct, because then I know if I reach a stack depth there, the recursion depth, the limit, I'm going to know that is because of the memory and not because there is a cycle in the thing. And the other one is going to be way more complex and difficult to think about if I make a mistake there, because then there's a lot more things involved as well. So I think the better approach is just to make sure that I have the correct way of thinking and the logic using this one and visualizing this one here. And then once I'm very confident of the way that it works and the way that I'm thinking about it, then I can go into the other one and extrapolate the logic and try to finish the other one. But it's going to be very difficult, I think. And I might not be able to do it. Like, if it is too difficult, I might have to think about another way to continue the other one. Like, maybe create another structure or change the goal entirely. The way that I'm thinking about the macro perspective of creating the simulations and everything like that. So, but it should be interesting. And I'm gonna learn a lot, I think. So, I'm probably not gonna come back today, but yeah, if I don't, then I'm gonna come back tomorrow probably and continue to do this. But I might come back just to show the graph. I don't know if this is gonna finish or not. It's supposed to finish because it finished on the other one. It finishes when I run here, so I think that it is gonna finish here. It's just gonna take a lot more time because it's creating all the stacks and creating the graph. And it's also gonna take a long time to load the graph. But then if I get the graph, then I think I might just come back to show like the other graph. But I might come back tomorrow. So yeah, and I'm gonna continue to do this stuff.